Hello, my name is Jason Vivori. I'm the collections manager here at the Berkshire Museum, and I have an interesting collection of objects to show you today. So very quickly, right here we have the tooth of a megalodon. This is a large prehistoric shark. These are massive. Think about this in comparison to today's sharks, which are probably about this big. So this is a massive shark. We also have 3 mineral samples. All 3 of these are listed as pieces of willemite, but they have different additional mineral compositions which have a very interesting effect on them as you can see them now, but also when we expose them to UV light, which we're going to do in just a moment. Also, over here, we have a canopic jar. This is an Egyptian piece. This is the jackal god Duamatef, again, guarding one of the internal organs, essentially. And this is alabaster. So it also phosphoresces very interestingly, and we'll look at that very shortly. So if we work our way over here to this first one, we have this shark tooth. Now, when you think of fossil, you're thinking rock. What's interesting about these is this actually does phosphoresce. I hope you can see that. Can you see that? Okay, so that's phosphorescing because of the dentin composition. There's actually organic matter that's phosphorescing. Your teeth phosphoresce under this sort of light as well. What won't phosphoresce are your fillings. So that's one way to tell where fillings are in your mouth. Anyways, so that's the shark tooth, the megalodon tooth that has this phosphorescence, this natural phosphorescence. Now the minerals, we have 3 different ones here. Right off the bat, this green one is typical willemite. It has a green glow to it. So you can see this is really just pretty much exactly what we have it listed as. That's what that glow comes from. This one, however, has more of an orangey glow. It is most likely because even though it's listed as willemite, there's a large amount of sodalite present. And that's what would be my best guess off of it. I don't know for certain. But based on what I can tell from using UV light, I'm guessing sodalite. This piece is a little bit harder to see, but it has a very pinkish sort of glow. That is most likely calcite, which can be usually bright red or pink and possibly orange. It could also, if there had been more of a blue in here, I think there's some hints of blue, but not that much, we could say that it might contain some fluorite. So the major ones we're talking about, why do they glow? Basically, these minerals become excited when they're exposed to UV light, giving off a certain level of energy, which creates the phosphorescence. And that's how you get this sort of glow. Some minerals glow more than others. It depends on how much of the particular material is present. Now, if we go over here and we look at our alabaster jar, it's a little bit harder to see, but you might be able to notice that there's a pattern in this. Although this looks like a white stone under normal light, there are layers, there are sort of rings. This is because this is basically sedimentary material. It's built up over time by deposits. And as different materials are deposited in this alabaster composition, they're going to phosphoresce in different ways, creating this ring structure that we can see when it's exposed to UV light. Even the top of the piece has its own unique sort of glowing areas. You can see that there's some striation in there as well. I hope you enjoyed this presentation on phosphorescence. You can expect to see a lot more of this in our new mineral gallery when we reopen.